Welcome to Kenton's videos. Enjoy the video.
You start by locking down the transformations. First, read the vertical asymptote. That gives you h because the log argument zeroes there. Once done, spot where the curve crosses a horizontal level that looks like a midline. That reveals k, the vertical shift. Next, find the point with y equals 0. That point tells you h plus 1 if the log argument equals 1. With h and k known, you've reduced the unknowns to the amplitude and the base. Now you determine amplitude A and base B using two precise points. Subtract k from both y values so you have a log b, x minus h, equals adjusted outputs. Then divide the two equations to eliminate a, yielding a ratio of logarithms. Use change of base to convert to natural logs and solve for b. Once b is known, substitute back to get a. Make sure your chosen points have integer distance arguments if possible. That simplifies. Write the full equation y equals a log b, x minus h, plus k using your found parameters, and then verify it against another graph point you didn't use to solve. You want predicted y to match the observed y with an expected graph precision. If it does, you're done. If predictions deviate, re-examine your asymptote placement and the exact coordinates you read off the graph, because small misreads or rounding when solving for b cause the largest errors. Adjust and resolve accordingly.
Thanks for watching. Consider subscribing if we helped you.